Okay, continuing the stoichiometry and mass, moles, and molecules. Let's look at a couple other examples. Mass, moles, and molecules. So previously we looked at converting moles to molecules. We can see that this actually works the other way. So if we said that we had 1.20 times 10 to the 24 molecules, and molecules of hydrogen gas. To convert that to moles, we just multiply by our conversion. So now we've got molecules on top, so we're going to need molecules on bottom. We're trying to find moles, so we need to put moles on top. So 1 mole is equal to 6.02 times 10 to the 23rd molecules. And so here again, molecules on top, molecules on bottom. So those units will cancel out. And the only unit we have left is moles. So 1.2 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23rd gives us 2 moles. So it just works the other way. Now say we wanted to convert something that, so one of the reasons we do this is, say we want to find moles. Well, we can never measure moles because that's how many of something you have. And we can't, atoms are too small, we can't count. But one thing we can measure easily, especially in the lab, is mass. So say we get some carbon, just maybe like a chunk of coal, or diamonds if we really like. But we'll put it on a scale and say that we have 24 grams of carbon. How many moles is that? So we start with, carbon. So one of the things, what's the unit, or what can we find, or what can we look up that gives us something that has mass and moles? Well, if we go back to our periodic table, we remember that this top number, which is protons and neutrons combined, is the atomic mass. And the unit is grams per mole. So for carbon, that is 12.011 grams per mole, which tells us, which means that 12.011 grams is equal to 1 mole. If you were to get 1 mole, put it on the scale, that's what you would measure. So you can go back and then start with what we have, 24 grams of carbon. So we're trying to find moles. So 1 mole of carbon is equal to 12.011 grams of carbon. So here, moles, which is what we're trying to find, we put up top. And the number that we're given, grams this time, we put on the bottom. So grams, grams. Grams divided by grams cancels out to 1. So the only units that we're left with is moles. And so we punch this into a calculator. I don't have one, but it's awfully close to 12. And so 24 divided by 12 is just about 2. So this tells us that we have 2 moles of carbon. So that's a way, and we can do that process in reverse if we wanted to. We could go from moles to grams. So if I were to say 3 moles of carbon, how many grams? Well, we've got 12.011 grams of carbon per 1 mole of carbon. So now, grams, the mass, which we're trying to find, is in the top. And then moles, which we know, is in the bottom. So these units, mole divided by mole is equal to 1, to cancel out. So we're now left with 3 times 12, which is about, tilde indicates about, which is about 36 grams of carbon. So that's how we can go back and forth from mass to moles, moles to molecules. Because we know going from mass to moles is, so mass in moles is molar mass. And that's on our periodic table. Moles, molecules, that is Avogadro's number. Our 6.02 times 10 to the 23rd. So mass in moles, we use molar mass. Moles in molecules, we use Avogadro's number.